Just struggling with a really hot and stuffy room. Okay, so it's my great pleasure to welcome today Eunice Oppon, who is a senior lecturer in Sustainable Future Department, and you've been there since January 2021.
Yeah.
Eunice did her PhD at the University of Sheffield and a master's at the University of Strathclyde in Glasgow. And she works on circular economy systems, sustainable global supply chain, and ecological exchanges in trade. She leads and collaborates on several impactful research projects, such as the Enhanced Weathering Africa Partnership Project. Maybe you'll talk about that. And yeah, today you're going to be talking about climate crops and crushed rocks, mapping the sustainability of enhanced weathering from line to field. Great. Thank you so much for coming to talk to us today.
Thank you so much. Thank you for inviting me to do this talk. So I will introduce myself again. I'm Eunice Oppon, and I have been with Exeter for a little over 4 years. The talk I'm going to talk about goes back to 2020, so that's about 4 or 5 years from my PhD, and then some of the things that have come out of it. So that's what I'm going to focus on today. Just a brief content overview of what I will talk about today. So I'll give a research bio about myself, and then I will focus on what I want to talk about, which is enhanced weathering, or sometimes called enhanced rock weathering. And then we will break down the keywords, so the climate, crops, and then crush rocks. So I'll talk about how enhanced weathering will lead to all these three. And then finally, I'm hoping to have some discussion and call to action. And so that's what we're going to talk about. Thank you for those that have joined online as well. I appreciate it. Okay, so a brief research intro about myself. I have to do this and give a disclaimer that because most of the things I'm going to talk about is in areas that's not my expertise, but because my work is such that it's very interdisciplinary, I find myself talking about things that I am, you can say, what we call a jack of all trades, but master of none. So, but in terms of what I do have expertise in is in supply chains, sustainable supply chains. So in the area of environmental economics, circular economy, that's where most of my research is in. Research on enhanced weathering, which I'm going to talk about today. I do some work on also trade. And so looking at when countries trade, whether there's any ecological imbalance that happens. So ecological and equal trade. And most of the methods that I use are quantitative. So I've just seen 2 of them here. Life cycle assessment, so that's LCA. So for that, it's when you want to quantify impact. So if you wanted to quantify the impact of, let's say, this bottle, there's a way to be able to say that, well, 1 bottle is equal to this global warming impact. So we can use life cycle assessment for that. And then input-output modeling, I use that for sectoral analysis and all of that. But basically, my work is on sustainability, quantifying impacts, whether the environmental or social, quantifying them, and that's what I do. So yes, so this is enhanced weathering partnership. I'll talk more about that, but it is very, very much in its inception phase. It's not fully done. Yes, we are hoping to launch it, but I will talk more about that because I'm hoping that for those that even watch the pre-recorded version, the recorded version of this, if they are interested, they can get in touch. So that would be great. And some of the journals that I've published in energy economics, ecological economics, and so on. So that's a little bit about myself. Now, let me go talk about what's the reason why we're here today. So if you are hearing enhanced weathering, sometimes you hear enhanced rock weathering. If you're hearing for the first time, I'm going to try and explain it in layman terms as I understand it, because it gets a little bit technical. I'm not a technical person in terms of the science part, but I'll try my best to explain what it is, and then I'll lead into the work that I do. So basically, the background is we know that we need to solve climate, all the climate challenges that we have, greenhouse gases, carbon dioxide being the main thing. So there's a lot of strategies that's coming up, and just coincidentally in Exeter, there is a conference that's an annual meeting of INSEC. So INSEC is a new carbon economy consortium. They started yesterday. I'll join in online to look at some of the strategies that has been talked about. There is this week as well, today's Monday, 30th June, Exeter Climate Forum is also having a series of talks as well. So for those that are interested, you can also join in. So clearly there is a lot, because we know that where we are, we need to reduce the global temperatures to 1.5 degrees and all of that. And so that means there's a lot of different technologies that have come up. I'm not going to go through all of them. Some of them is as basic as planting trees, afforestation, reforestation, or direct air capture, where we have these machines that suck the CO2 out of the atmosphere. But what I'm interested in and what I always talk about is the sustainability of these measures, right? So as we are coming up with this, how sustainable are they, right? And by sustainability, I'm really talking about the three pillars, that is economic, environmental, and social. For me, I have been looking at enhanced weathering, and that's what I'm going to focus on. Like I said, this is from my PhD, and then I'm still researching on it anyway. But enhanced weathering is basically spreading of rock dust on croplands for carbon capture. When you say this, it's like, so how do we move from climate, crops, and then how do we capture that? So to help me out, I'm going to let us watch this video. This is a video by one company that does enhanced weathering. They are called Undo. They are in Scotland, I believe. And so they are going to talk about the operation. It's a very short video. Let's watch it and I'll come back to it.
Enhanced weathering is the acceleration of natural rock weathering. As the rock weathers, it captures carbon and locks it in for thousands of years, and it can be used and accelerated for use on a global scale. This beautiful rock is basalt, a mineral-rich volcanic rock that forms when molten lava cools. The basalt we use is an existing product of the quarrying sector, so we aren't using any additional energy to procure it. By spreading it locally, using existing farm machinery, our operations have a 95% carbon efficiency. Basalt is also one of the most abundant rocks on Earth, which is helping us scale up our operations. The crushed basalt we spread is 0 to 4 millimeters, so a maximum particle size of 4 millimeters down to a really fine powder. By increasing the rock's surface area, carbon dioxide is captured approximately 50,000 times faster than in the natural world. The silicate rocks we spread are tested to ensure they're always safe. Carbon dioxide is the greenhouse gas that we need to get out of the atmosphere. And during the natural biological cycle, the carbon dioxide ends up in the soil as a mild carbonic acid. The basalt captures it, turns it into bicarbonate ions, and these are washed out to sea. We're taking it from the biological cycle into the geological cycle, and this is what we're excited about.
We're now at Muirhouse Farm just outside Carnwath, which is an organic dairy farm. They're receiving some of the enhanced weathering fines from the quarry today. The fines will help for crop yield, soil health and pest resistance. We utilise the local agricultural community whenever we spread the enhanced weathering fines. We use local contractors, local hauliers with good reputations to make sure that we keep the money in the local community. Because we're using local contractors, they feel more comfortable taking the enhanced weathering fines. We're helping to lock up CO2, and also the farmer's getting a good degree of nutrients and trace elements into his soil and helping to improve his soil health.
We've been working with the organic certification authorities, and we've had this material certified for use on 4 of the leading organic certification bodies. There are 3 parts to modelling the carbon dioxide that we lock away. One is the analysis of the rock dust. Using precision instruments, we know exactly what's in the dust. Number 2 is we use this data to model the rate at which the fines break down as they react with the carbon dioxide that's dissolved in the water. And number 3, we use full use of GPS technology, so we know how much carbon that we're using in the haulage, in the spreading, and also how much we're capturing it. We process this information and we can calculate how much carbon dioxide we're locking away for thousands of years to effectively help create a net zero future.
So I like this video because whenever I use that before I come to this, my slide, it makes it easy because at least it's talked about most of the things. So basically, rocks weather, they break down. And this is a process that happens even without us having to do anything. So we call that the natural rock weathering. And so what happens, what you're seeing on this screen is atmospheric CO2. So the CO2 that's already in the atmosphere, when it comes into contact with rain, water, it forms carbonic acid and it falls on these rocks. It's not every kind of rock that reacts in the way that would help to more like get the carbon, but there are certain type of rocks. We call them silicate rocks. So basalt is one of them, olivine, wollastonite, there's a couple of them. So these companies like Andu was using basalt rock. And when they react and the breakdown, so part of the weathered byproduct is the bicarbonate, that's the ACO3 that finally finds its way into the ocean and then is stored for a long period of time. So that's how natural rock weathering it works. So there's an article I wanted to put it, but I forgot. So I'm just going to tell you about it. So there's an article that came, I think, last year, Science of the Total Environment, and it was talking about the fact that in the UK, natural rock weathering has the potential to sequester about 7 million tons of CO2 annually. So this is us not doing anything. So this is something that happens. Obviously, it would take a long time if we want to rely on that. And so that is where enhanced weathering comes in. Can we increase the surface area of these rocks instead of the rainwater forming or falling on these big rocks? If we can get them in these particle sizes that are, and then spread it on a flat surface, then hopefully we can aid it. So that's what enhanced weathering, the process is about. So clearly there's a supply chain element to it, the mining of these rocks, the grinding, getting them into that fine particle and spreading them on cropland. Although there have been some studies saying that we can spread it on coastal areas. So for those of us in Cornwall, there's a lot of beaches we can. However, the reason why cropland serves as an alternative that is way better is because we already have some benefits for that. And I'll talk about that when I'm talking about enhanced weathering and crops. But there's a lot of agricultural land. And so why not use this existing than just spreading it on the coastline? I'm going to let us watch this video because it's a question I get along that, yes, so you've explained that mining of rocks and all of that, but how do we get to see, after we have spread it on the cropland, on farms, how are we measuring to see that actually it is capturing CO2? Right, so this is a video from the carbon community. They interviewed some colleagues from Imperial College, and I like what they talked about. And I also like to use it because it's not my field, so you can all listen to it. So I'm going to let us watch how we measure carbon removal.
The carbon community is running one of the world's very first field trials of a way to remove carbon dioxide from the atmosphere.
Yes, I can hear you. Thank you.
Weathering.
You can hear
This relies on the reaction of carbon dioxide in the atmosphere with silicate minerals, including basalt, which I have here. So what we need to do to make sure that this works is to actually verify that the basalt is reacting with carbon dioxide, breaking down and releasing the weathering products that are ultimately stored for a long time in the ocean. So our lab is developing multiple ways of measuring the same information so we can be absolutely sure how much of the basalt that we're applying to the new growing forest at Glandier is actually capturing carbon dioxide. So one way to do it is to cut a block of soil out of the ground and to extract all of the moisture that's retained in this soil and look for the weathering products in that moisture, because most of them, of course, will be dissolved into the soil solution. Another way, which we've shown you before, is to use an instrument called a lysimeter. And this is basically a very large ceramic hollow tube that goes into the soil and pulls in moisture from the soil solution. And so we have some of that here. And we can analyze this in the lab to see how weathering products accumulate in it. And the final thing that we're doing is making something that's called a litter bag. And so this is a very, very fine mesh. It looks solid, but there's actually little tiny holes. And we will be putting a known quantity of the basalt inside of this bag, sealing it up and burying it. And then at predefined intervals, we can come back and weigh this bag and see how much of that basalt is actually dissolving and weathering and capturing carbon dioxide. So we think this field trial is really special. It's not just because of the size and the replication, but also because of all the effort we're putting in to make really sure that we're measuring this carbon dioxide removal process as accurately as we can.
Okay. So this is the aspects way of talking about how we want to move from here. It works. But I want to just do a recap of what we've learned so far about enhanced weathering. So it involves spreading of crust silicate rocks, right? And I've mentioned some of these rocks. There are different types on farmland to capture CO2. And the fact that it is basically we are enhancing a natural process, right, by human intervention. So we actually finding ways to make this faster. It has co-benefits, and that is one of the reasons why I said that instead of spreading it on the coastal land, right, it is better if it's spread on farmlands because it has some impact on soil fertility and crop yields. And so that's that additional benefit that comes with our core benefit of enhanced weathering. And so it is not to replace one technique or one carbon dioxide removal technique or the other. It's basically that enhanced weathering or EW can form part of that portfolio of climate mitigation solutions. But now so now that we've done with the science part, a little bit of that, why this talk and why now, right? What are we looking at? In finding, these solutions, we need to make sure they are scalable, right? And so we can actually do it on a large scale. And enhanced weathering is gaining a lot of traction. And I think there was a parliamentary post about it, and you can go check it out. But I really like how condensed it was. So it's gained a lot of traction. I remember when I started a PhD, so this was in 2015. And at that time, the Leverhulme Center for Climate Change Mitigation had won this grant to just do this research for 10 years. So they must be finishing in this 2025 period. So at that time, there wasn't a lot of studies, whether field trials and all of that. But one thing that was definitely not there when I started was the sustainability element. Are there any sustainability trade-offs? Is there a situation where, yes, we are capturing CO2, but then is there an issue about social equity, the farmers that have agreed to do it? So those kind of what we call measurements are really underexplored. Obviously, I will talk about some of the research that's out that I did with some colleagues. And so it's still underexplored, but it is better than those times when I started researching on it. We need to know, is it environmentally viable? Is it efficient economically and socially? Is it just? So that's the kind of research that I look at. And I'll be happy to hear your suggestions because I have a lot of questions at the end, not questions for you, but questions that I feel that is important. Now, the kind of approach that I take and I feel is looking at it from a life cycle or systems perspective. And so most of the time when you look at any technology or any product, let me just even use the word product, upstream impacts are usually cut off, right? So by that, I mean, in order to produce this bottle, for instance, whoever Kirkland that produces, it's not Kirkland, okay, whoever produces this bottle, right, they would rely on other suppliers. Those suppliers rely on other suppliers. So it's really a knock-on, effect. And to be able to capture that, you need models like the input-output that will be able to capture all through the sector. So that's what I mean by the upstream impacts, and not just look at what is happening at the farm or whether the mining company that is supplying the basalt. So beyond that, so mining company will rely on other sectors. And I'll talk more about some of the papers I have. So most of the research that's been done is showing that when it comes to the production and then transportation, that's where there's very high energy demands on the supply chain of enhanced weathering. And then we're looking at emissions. So I have some research that look at the emissions over the entire supply chain, or either at the production side. Some look at emissions when we are spreading it, so on the farm, and also labor issues, right? And land use and all of that. So these are some understanding the effects of that. And so I've just talked about, not to belabor the point, but some of the tools that I use to measure that. That's life cycle assessment and then input-output models for that. I'm going to go through some of the papers I've published with colleagues. Some of them I think are online. So there's this paper in energy economics that was talking about sustainability performance of EW. And so looking at all the triple bottom line, this paper precedes that. So the macro level economic came, and then after that we got data from social hotspot database. So that is a database that will have data on working conditions, on smallholder farmers, and they've quantified it. And so we're able to use that to do this, the one in energy economics. And then I've talked about why this approach is taken, at least from myself and my co-authors, because we know that the large scale mining of rocks will impact other sectors. And so when we use input-output, then we can make sure that we're able to model what is the impact on the energy sector, on machinery, and all of that. So that's the approach that we take. And we did this study looking at a couple of top global emitters. I'll just give you some summary findings on that. So that's the paper I'm talking about. So this was 8 countries. We looked from UK, USA. We put it into developed and emerging economies. And there's a lot of findings, but what I want to focus on the fact that, so for countries that were not performing well, overall environmental sustainability was based on their emissions and energy use. So countries that had high energy use. So for instance, it's not here, but I'm just, Germany compared to the other developed economies had high energy use when it comes to enhanced rock weathering. UK did not fare very well, The environmental sustainability too, for those that had high global warming impact, for instance, and countries like India, China did not perform so well. And so that paper really sort of ranking the countries and where, and then we looked at some social elements, social and economic, like labor conditions as well. So we are talking about decent work. Among the developed economies, UK, France, Germany, they all did super well on the social metrics. USA did not do so well when it comes to labor conditions and decent work, and the metric that we use. So these are the things, so that when a company says that I have 1 ton of basalt and it can remove 1 ton of CO2, we are saying that you should also work out what is the associated environmental impact or social impact of that. But the takeaway from this paper was the fact that countries differ, and the differences in the environmental sustainability and their enhanced weathering sustainability is based on the policy environment and the context that's happening within the country. It mirrors that, right? Now we go to the crop part. So we've done enhanced weathering and climate change and how it works. Now, enhanced weathering and sustainable food production. So we're talking about the crop, why cropland and why that is important. So for this one, I have talked about the fact that there are trace elements that you can find in some of these rocks, and they are good for crop growth. And so you saw in the undo picture that video that we showed. For those online, I think you didn't get to hear, but it was basically, you saw the video talking about spreading this on farmlands as a fertilizer. In some cases, sometimes as a supplement. So it's not to actually replace fertilizers, but as a supplement. And so these are companies that sell these volcanic basalt rock. There's a company called Remen in Scotland, and in Devon, there is Mother Earth Minerals. So you can buy, for example, 1 kilogram of volcanic rock for £5, right? So this is something that is already there, that some people are already buying it and using it in their farms and all of that. So this study that we did wanted to find out if we compare basalt rock does to the traditional PK fertilizers, industrial fertilizers, right? So which one has is more environmentally sustainable? And so what we found out through life cycle assessment was when you use the basalt rock dust, it has minimal environmental impact than an industrially produced fertilizer. So that's what we found out. And so it can really form and be a good solution for be a good solution for sustainable fertilizer production. So that was one paper as well. Now, enhanced weathering also has, some relation with circular economy. So how we most of the time, and you saw it in Andu, you don't have to mine fresh rocks per se. Sometimes they use these mine tailings to do that. Because they have already been stockpiled for a long time. So if we can find a way for mining companies to be sustainable, and instead of this being stockpiled, if we can get it and use it and it can get onto the farms. Obviously, recovery is challenging because, and I remember talking to one colleague at the Common School of Mines here at Exeter, and talking about the fact that sometimes you will get the mine tailings, but it is not fit for purpose, or you might have to do some testing because there might be metal toxicity and all of that, and no farmer wants you to go and spread something that, so it is not as simple as that, but that's the model that is happening with some of these companies, and I'm going to talk about companies that are already doing that. This is a working paper. It's not yet published, but this paper, we're looking at the basalt rock, so which I'm calling natural basalt, and artificial silicate. Remember that I said that it works with silicate material, right? But there are some sources of this silicate, which I'm calling artificial silicate bearing materials. They are the byproducts. So for instance, you can have the cement kiln dust or steel slag or coal ash from these processes that are already energy intensive and emission intensive, but then they produce this waste. And if we can use this to also capture CO2, that would be great. So there's a lot of field trials that is happening. But what I am looking at is which one, once again, would be environmentally sustainable, right? Should we go for using these artificial silicate waste or the basalt? So that's the paper that's a work in progress. We're not done with it yet. Now, my favorite part of the presentation, not to say the rest were not favorite, but this is the part I like it because I want to be able to explore thoughts and what people think. I'll give you some ideas about what's happening from research to practice in enhanced weathering. So there are a lot of startups, some of them in the UK. So I've talked about Andu UK. Andu is in UK, Lithos is in the USA. There is Implanet in Brazil. There's Flax in Kenya. Flax is the only company that started in Africa and solely for enhanced rock weathering. There's an alliance for those that want to check out on this. There's Enhanced Weathering Alliance. This is a map I took from their site showing the different startup companies. And you can see there's a lot in the global north. Global south is picking up a bit. But most of them, the only one that is headquartered in Africa is Flax, which is in Kenya, but they've started some deployment sites in some countries like Zambia, Tanzania, and the rest. So this is what's happening. Most of these companies are selling carbon credits. They have the voluntary carbon market, and then so their carbon project is based on enhanced weathering. And so this brings me to important questions I've been asking myself and trying to also see how I can collaborate with people that are interested, and then, I'll be happy to hear your thoughts. So yes, there's an intersection between mining, farming, and climate, but the important questions I feel that we should ask is who's benefiting when we set up this system? Are smallholder farmers involved, or are we dealing with just commercial farms, right? In countries or in a region like Africa, where there's a lot of countries that have agriculture being the backbone of the economy, and the smallholder farmers are involved. To what extent, right? Are they benefiting? Are the carbon benefits equitably being shared, right? Which is important. what gets measured. Now, I like this because when you look at, if you type enhanced work rendering, you will see a lot of things about measuring, reporting, and verification, the MRV, because no one wants to buy a carbon credit that is not certified, that is actually doing the work. And so there's a lot of field and lab trials. But I feel that beyond what gets measured, these kind of things, we should look at the sustainability angle as well. So that's what I mean. Is there equity and long-term sustainability of it, right? Supply chain, the transport emissions, what is the distance from, let's say, a mining company to a farming community that we can spread it on. Right? So these are some of the concerns, local community concerns as well. Are they open to, because there are some areas where the community already have some kind of aversion to mining companies being there. Are they open to the fact that now we are going to get some benefit from them? What are their thoughts, right? And so local community concerns, awareness is important. In the UK, there was a study which took a social dimension by Emily Cox, who is part of the team when I started, and we're looking at the awareness of enhanced rendering in the UK. And so, there was low awareness as at that time. I suppose now that there's been a couple of years, maybe this is gained. But when you go to other parts, it's not that, popular. And I'm really interested in the smallholder farmers. So inclusion versus exploitation. Are we looking at making farmers active stakeholders, right? So not sites of experimentation when we say, oh, I have this, this is great for the climate. Why don't you allow me to spread these rocks and then it will help. So it's basically they are just the end user who is not an active stakeholder, but I think that it shouldn't be that way. So there is a risk that the farmers who are the end users of the enhanced rendering supply chain will be seen as just labor and landowners. And then the decision and then the profits and the benefits can flow elsewhere. There was an article that came saying that one of the high cost on carbon projects is the MRV. It's goes so companies spend a lot of money on achieving that. And although that is great, so that would mean that for a typical carbon that credits of whatever supply, what is the money that gets to these other users who are also active stakeholders? Without them, the whole process falls down. And so the opportunity here, I believe, is co-developing these enhanced rendering interventions so that it fits the local goals, the land practices, because every place is different. Instead of it being something that, and I think I'll talk more about knowledge transfer, and maybe I should just, because of time, I'm just going to go further to that. Knowledge transfer versus knowledge exchange. For me, I've always had a slight issue with knowledge transfer. It's great, but knowledge transfer depicts this thing as there's knowledge here and there's no knowledge here, and knowledge is moving from there. I like to use the word knowledge exchange. And so for that, and that's how I feel enhanced rendering would also work, because the farmers themselves, they need to have access to that information. They need to know what is the effect on my crops, right? What happens if I spread rock dust? It needs to be accessible, and not just to the geoengineers who are getting the rocks, or the geochemists, or the soil scientists. It needs to be available to them as well. Capacity building, therefore, should be two-way, right? So when you go to them to want to maybe try out enhanced work rendering, they already have their traditional ecological practices that they do. So it has to feed into them in theirs as well. Compensation and decision making is also important. Will they be fairly compensated, right? And so on the news, if you just Google, I think Microsoft had, these are some of the bias, right, from these companies. Microsoft, there's another couple of, these big, they are trying to take away their residual CO2. And so they are ready to go into pre-purchase agreements with these companies. However, how much of that money is also flowing to the farmers, right? So compensation, even if it's not money, are they compensated in terms of soil enhancement, right? And would they be open to that? And beyond the conversations, they must feel, I think that they should feel that they are part of the decision making. So it's not something that if you go to, I'm going to talk about the last couple of slides, enhanced Weathering Africa Partnership. It hasn't been launched. We are still in the development phase. But one of the things that you are going to find is if you go to a typical farmer and say that, oh, this is good for the climate, they care, but they don't care that much, because what they care about is the impact on their farm, right? So as much as they care about the climate, they care about whether this thing will affect their crop use or it will increase their crop use. So they need to be given a sense of agency, whether they want to participate or even how they want to participate. So in conclusion, can enhanced weathering be sustainable? Yes, it can, but like I've been saying throughout this talk, it needs a life cycle system, not just looking at just one part of it. How are we getting the rocks and getting it onto farms? We need a life cycle, full life cycle system thinking. And then MRV, measurement, reporting, and verification is good, but I think what is equally good is the sustainability element. And so if a buyer is going to be happy to buy a carbon credit based on enhanced weathering, and it's just the fact that, oh, it's been certified by, I don't know, let's say isometric, is great, but there must be a report as well that shows that this is the impact, this is the number of farmers that it has impacted, this is what they term as impact, because sometimes what you term as impact is not impact to them. So so that's what I mean. So the sustainability element, the social equity, that part should also be measured. And for that, I feel that we should integrate all these things that covers the triple bottom line: environmental performance, social equity, and local stakeholder voice. And collaboration is important, right? And so across disciplines, clearly you can see that this is very interdisciplinary. It just can't be one discipline doing that, so it cuts across. And also geographies as well. And in talking about that, now that leads me to the last slide, which is enhanced weathering, last but one, enhanced weathering Africa partnership. So having done this research after the publications came out, so this is 2015 to 2025, it's been 10 years. I felt like that is, doing a PhD and then writing on it. I felt like when we started, there wasn't even any company in Africa. It's just 2 years ago or so, or 1 year, that flash carbon came. So I felt like, and yet, when you look at the science of it, weathering works well in tropical regions as well. At least it increases the weathering rate. So I feel that having a partnership like this will be great that is focused on enhanced weathering as a climate solution in Africa. So that is what this initiative is hoping to do. And you can check more on the website. But basically, it's two things that we want to do: build a collaborative alliance. So there are already mining companies in most of these African countries. There are farming groups already there. There are research institutions. And then there are already, projects that are available. I come from Ghana, so I have started talking with some of the, so Ghana is in West Africa, and some of the scientists that are already there. I'm working with the Council for Scientific and Industrial Research and working with their soil scientists, and so that we can see whether we can get these places, working with the Food Research Institute also there. And so that we can have this collaborative alliance. And when these papers are being published, it is not just based on countries in the global north, but also in the global south, to see whether there are any differences. The second objective is to create a knowledge hub for some of the research and feasibility studies, so it's easy to go there, policy briefs, and then webinars, videos that captures the work that is being done in enhanced weathering. So finally, a call to action. Yes, so this is me. For those who watch this as the recording, if you're an agronomist, geologist, social scientist, I'll be happy to, if you want to reach out, policy experts. And also I want to take those in the room and online. If you are interested in collaborating, it would be great, or any thoughts that you have. We need data. Data is at the heart of enhanced weathering on local soil responses. So when you spread this on sugarcane in the Middle Belt in US, or you spread it in some farm in Scotland, and if you spread it in a cocoa farm in Ghana, I suppose that there's going to be different local, soil responses to it. How does it work and all of that? Insight into where the mining residues are. In fact, one of the main challenges I faced in coming up with EWAP is even mapping out where to get this rock, because it's not every type of rock, and trying to get companies that would who even understand this and by that I mean the mining companies who will be willing to incorporate this into their circular economy strategy. But not knowing where they are can be tricky, not knowing, and so if we have data on where the feedstocks are, it would help. And obviously the farmer perspective and the community perspective, because they need to, like I said, they care about the climate, but they care about their crop yields. And without them, this whole system breaks down. So you can have miners and the mining company ready to give out basalt rock. You can have companies that are facilitating this, getting it to the farming community. But if they are not, they don't want it then it doesn't work. So it only works when it's really enhanced by getting it on that surface area we talked about. So anybody that has any interest in joining Enhanced Weathering Africa Partnership will be great. We've submitted some couple of grants. As usual, very competitive, hasn't been successful, but we keep going. If you are interested, it will be great for us to collaborate. And I'm trying to time myself to 40 minutes. I've gone a little bit above that, but thank you for your time. Thank you so much.
Brilliant talk, and talk about interdisciplinarity for a project. Absolutely fantastic. Any questions online or in the room?
So Eunice, we held a workshop here a couple of weeks ago about soil health, which seems really relevant. It was a combination of different disciplines, but a lot of the emphasis was on kind of microbial communities in the soil, looking at regenerative farming practices and how they enhance soil health. And it just strikes me that there's quite a few possibilities to tie your work into that network. You are kind of exploring opportunities there. But I just wondered specifically, because you kind of touched on the fact that this is kind of competitive in terms of traditional fertilizer use, in terms of enhancing crop yield and the quality of the crops. Is there much evidence around that kind of how that improves the crop yield? Because the feedback in the workshop we had from the farmers was that they don't really care about the mechanisms. They want to know that it works. And so I just wondered if you could just touch on that in terms of are there people doing that research into that, the positive?
Thank you so much. Most of the research that I have glanced through, because I just want to know what's happening, has been based in the global north, and they do field trials and lab trials that shows that there was an increase in crop yield. I, however, struggle with causality. That can we say that just but they always start with a baseline measurement to see what was there before they applied it. Or there's only one research I've seen in Africa by Flax Carbon that they applied, and they said that it didn't work. But the issue with I feel that, and I didn't talk about this, is I'm really struggling. Just a minute. Not confident. I feel that there's a lot of uncertainties. That's what I'm going to, and this is me talking from a layman point of view, whether this really works. So you can have that basalt, apply it on, say, sugarcane, and then it will not give the same impact as it would. right, in, let's say, cocoa. So there's a lot of uncertainties on that. And sometimes too, the uncertainties that I've read about is also how long it takes for the carbon to be captured. Different timescales have been given. There's not a real consensus on that, whether it's going to take years or not. But most of the pre-purchase agreements, they would buy the carbon credit against saying that we will capture the carbon in 2030. The farmer is not interested in 2030. So they want to know, because by that time, you have been spreading this for a couple of years. So for them, there's a bit of hesitation in trying to talk with the farming communities. Yes, fertilizer is expensive, but if this is also not going to give them any, so I guess the long-winded answer is there's uncertainties. I'm not so sure if it works. But although, yeah, you can find a ton of them. Biology letters, they publish a lot of research on enhanced reduce showing that it works with crop yield. But yeah, that's what I can say. Thank you.
We have 2 questions online. We're going to start with a question in person, and then we'll have a question in the chat. And Duta
in Jenga.
Yeah, Nduta, thank you. Can you hear me?
Yes, absolutely.
Okay, great. Thanks, Eunice. That was a really good presentation. I just have a quick question on whether there are certification or standards for MRV of carbon capture through enhanced weathering. And I'm sorry if you covered this, but I joined a little late, so I might have missed this.
Okay.
Thank you.
Okay, thank you, Rita. Yes, so it's very new compared to the other certifications. So there are companies or certifications called isometric, recently came up. I think that was just last year, where they have their own MRV. So for companies that want to be able to get that certification, one company is isometric. There is Puro F, I think, or Puro something, yeah, that also have a standard. So they have come up with a methodology for measurement, reporting, and verification. So some people also go for that. What I find is there's no consensus. I think even with the other, the mainstream, these ones, Vera, Gold Standard, they are still coming up with that, So, but isometric and Pure Earth is the one that I know that, and some of these companies too, by the way, they start their own kind of certification programs from MRV. I don't know if you still have a hand up? Or
yeah, thanks for the answer. But also I just wanted to make a quick comment. I looked up EWAP and it's not coming up online. So maybe the website isn't up yet, but it's not coming up.
Okay, so I'll drop it in the chat, but it's EWAP project, so just in case, but I will have a look at EWAP and then project.
Cool, thank you very much.
We have one question. If you could reuse mining waste, that'd be a great step towards circularity. I'd be curious to know if the long-term impacts on crop yield, this would have an impact on more farmers adopting this approach. Also, I know a geologist and mining engineer from Exeter that I can put you in touch with. Sounds brilliant.
All right.
So yeah, you've already touched a little bit on crop yield.
On crop yield.
And it feels like, is there really no experiment going on around?
There are experiments going on. And so what happens is, and this is one person I was talking to in Adelaide, who they have the machine where they test it. The first thing they were like, if you want to do this, we need to now test the composition of the rock. If it has high metal toxicity, it doesn't matter the fact that it is basalt. We have to find a way to either reduce it and, if not, you can't go spread it. And then it's almost like you're giving false hope to the farmer. But then for you get to say that you are capturing CO2. Obviously, the basalt will weather. It will capture CO2, but at what cost? At the cost of the farmer's crop yield or what? Yeah. So there are, I know I've talked about that, but short answer, yes, some trials have worked, and that is true. But the long-term effects, we really don't know. Enhanced reading has not been there for that long, so we really need, long evidence to be able to. Some have worked, and others too. I guess they are still in the process. Yeah.
And it would be interesting to look at with some microbiologists the effects potentially on some of the microbial communities of if there were toxicity within the
Yeah.
and the ecologists as well in terms of, fauna of the soil and
Yeah.
birds and everything. I think
Yeah.
there's a lot of projects. I was wondering about the incentive to the farmers. Are there any incentive in the UK or world in different countries? Is that already in place?
So for some business, because I don't work for any of these companies, but I have researched a bit about them. Sometimes there's a compensation they offer because as much as you're talking about crop yield, some of the farmers will only agree if there's an immediate benefit because essentially you are using their plot for experimentation. That's how they see, because you need to now see whether it works. So they need an immediate benefit. Then the second thing is the fact that they are told that hopefully there will be crop yield, soil enhancement. And so that's something that they like to, because most of these farmers, at least they don't have to pay for laboratory costs to go test their soil. This is part of the package, then they like it because they feel that you are doing something. So that's the compensation that, at least the model that I see. As to numbers, I don't know the numbers that get to them, but I know that some part of the money goes to compensate them for giving up a portion of their lands for this. Yeah.
Really interesting. Any more questions online?
No questions. Brilliant presentation, Eunice.
Thank you, Frank. Thank you so much.
Great. Thank you again, Eunice. That was a really, really interesting time.
Thank you for making time for those that joined, and thank you as well. Thank you
Great.
for spending your Monday afternoon here.
There is actually another question that
Okay.
I don't know. We have a few minutes. Do you want to take it? Sorry, Joseph. Do you think there's a risk of mining companies to use it as a greenwashing while keep their harmful actions? As a way of
Short answer, yes, but that it wouldn't be the enhanced hydrogen is not the first thing to happen that mining companies want to use for greenwashing.
Yeah.
And so I wouldn't say we should that it's going to just be a greenwashing tactic.
Okay.
I don't think so. I think they have a stockpile anyway. So for this, if there's a benefit to the mining companies, great, but there's an actual real benefit also. So we shouldn't just look at it as, but yes, yeah,
there is.
obviously.
Okay.
Thank you so much.
Thank you again.
Right.
Thanks, online.
Enjoy the rest of your Monday afternoon.